Hello, we are the Intelligent Ground Vehicle Competition Team, or IGVC for short. We are the Maverick Machine and myself. We have 14 members. I am Caleb Rivera.
My name is Brian Quintero.
I'm Ethan Job.
And I'm Shreya about to.
Starting off, we're going to talk about the summary. So the Maverick Machine is an intelligent ground vehicle, and we will compete at the 2023 IGVC, which is the competition that will showcase the CSC department of UTA at the event. The IGVC is an autonomous course where ground vehicles must navigate through and avoid obstacles while following the rules for competing for the best time and design. First, to start off with us developing this project is figuring out the different components to make an autonomous vehicle. We have separated this into four main layers, one of which is being the safety layer, just to make sure that we notify all people around the vehicle, which mode, if it's armed or inactive, and also a way to communicate to wirelessly or wired stop the vehicle in case of it starts to run away on us. The three other main layers are going to be the eyes, the legs, and the brains of the autonomous vehicle. First is the sensor layer, which will include an encoder to know how fast the vehicle is going at any point in time, a LiDAR to detect objects in the distance from the vehicle, a cube orange in order to deal with getting the vehicle moving to GPS locations, a camera to see the white tape as the boundaries of the competition to make sure that we stay within the track. And then lastly is an RTK GNSS, is a GPS to help us with accuracy of finding where the vehicle is located during the competition. The next layer is the legs layer, which is our movement layer, which just has the two motors on each side of our wheelchair base vehicle, connected with a car battery underneath with our power supply, as well as a motor controller. And then lastly, we have the brains layer, which is the controller layer. And for here is mostly our software, which is Mission Planner, and also a remote controller. That way we can manually control it if we need to.
Next up, we have our software. We use Mission Planner. With Mission Planner, we're able to configure stuff on the robot, such as PID or how fast it can go. A big advantage of using Mission Planner is that we can actually plot waypoints, and the vehicle will head that direction via the waypoints.
So the University of Texas at Arlington has its involvement in the competition dating back to 1995. And this year we aim to participate with the goal of showcasing our skills in design, construction, and team management. Also to showcase our computer, the CSC department at UTA. And we also aim to inspire incoming undergraduates with the project.
And for the hardware design, the vehicle consists of an electrical wheelchair as the base of the rover. And if you can see the orange box in the middle, this is essentially the heart of the rover known as the cube orange. And that's why it's placed in the center. To power every hardware component, it will need a 24-volt battery. The 24-volt battery is just 2-volt batteries that look like car batteries in series circuit to provide power to all the system. And if you look at the blue boxes to the left, this is how we move our motors using a motor controller called Sabertooth. And for safety concerns, we added a red button on the vehicle to serve as a mechanical e-stop, and also wired a wireless e-stop so we can power off the motor whenever we can. And for the red boxes on the right, we have our safety light and camera to also help us control the vehicle. This part of the system is still not yet finalized, and changes could be made later on. And finally, we have the transmitter at the bottom. This is an option where we can manually control the vehicle and also control the modes of the vehicle. And that's it for the hardware design. In this video, we're moving the vehicle in the manual mode at the parking lot. And also our plan is to continue working on this vehicle and until the competition, and do our best to represent UTA.
To finalize everything, while we are still working with completion of this project, the design of the Maverick machine complies with the rules and regulations of the competition. Work on this project has provided us with valuable technical knowledge, design skills, problem-solving abilities, collaborative skills, and hands-on experience with practical applications. The Maverick machine expresses gratitude to Professor McMurrow and everyone else who has provided professional guidance and assistance throughout the project. And thank you so much for having us at Innovation Day.
Thank you.